So let's just say here's a roof, and I've tied a cable to the roof, and from this hangs a mass. Right, so there's just the cable, there's the roof, and I've got some sort of mass, and as you said, everything is stationary. So let's apply what we know about laws, about forces, to this problem to figure out what type of forces are there in this cable and what are their properties. So let's start to draw a free body diagram. Let's just look at the mass first. So I've got the mass. I know it's got a weight. So it's being pulled down by gravity. So that force is just its mass times gravitational acceleration. Right? But it's going nowhere. So it's not being accelerated. So there must be some sort of opposing force. So something holding it back. So there must be a force from the cable on the mass. And let's call that just for now T1. So this is the force from the cable on the mass. Now let's think of this cable. Let's try to break it up into the tiniest little sections we can think of. So let's zoom in on the section of cable right above the mass. So if I try to remember, the engineers can correct my horrible drawing, but this is to illustrate just a section of cable, right, that I'm zooming up. Obviously there's cable above, cable on top, but I'm just isolating one section. Now remember, when we do problems like this, we are always going to assume the cable cannot stretch, and we're never going to reach the limit where it breaks. So that's not a problem. Now this piece of cable is also stationary. If the mass is just hanging there doing nothing, the cable is just hanging there doing nothing. But we know there's a force from the cable on the mass of T1. From Newton's third law, it means there must be an equal but opposite force from the mass onto the cable, which is also equals to T1. But again, this cable is not accelerating. So there must be a force that opposes this, and it must be exactly the same magnitude. Otherwise, there would be a resultant force that's non-zero, and this piece of cable would be accelerating. And we can do this for every section in the cable, all the way up to right here where we've got the roof. And if we were to look at that, so we zoom in on that, we've now got the roof. So there is a force from the cable on the roof, which will just have to be equals to, again, the tension. And obviously the roof is not falling downwards, so however the roof is supported, it counters this force exactly. So we can say that that's some sort of normal force or whatever. So that's why the tension everywhere in the rope is the same. And this is something that we can use when we solve problems, as I'm going to do right now.